Here in this video, we are solving a current electricity problem that appeared in a NEET 2025. The problem is like this. We need to find out the current passing through the given circuit. The circuit is very much visible for us. We need to find out the current passing through the circuit. If I have to find the current passing through the circuit, the first thing is I have to find the effective resistance of the circuit, because the voltage is given for you, the EMF is given for you. If I know the resistance of the entire circuit together, I can write Ohm's law, V equal to IR, and find out the current in the circuit. So my first aim is to find out the effective resistance of the circuit. It looks like a little complex circuit, so I need to simplify this circuit. And you can see there are things like multiple resistors, and it is kind of resembling a Wheatstone bridge. But I need to check it is actually a Wheatstone bridge or not, and that bridge is in a balanced state or not. For that, let us go a little deep further. What you can notice a little closely is A and F. Between them, there is no resistance. It is a simple line. That means a zero resistance. That means the points A and F are not different. Similarly, the points C and D are also directly connected. They are not different. They are the same. So I will start our discussion from there, right? This point is A and F. This point is C and D. Both are same. Between A and F, that is this point, and C and D, that is this point, there is a resistance of 6 ohms. Let me connect that part first. So I am trying to draw a simplified version of that circuit, 6 ohms. So this part was already taken care in my circuit. Now let us, if you look little carefully, from A to a point like B, we are having a resistance of 5 ohms. So let us connect him from A. Of 5 ohms. So this part I am talking about, this part that I have already drawn, right? That is connected to I connected to a point B. You can call that point as B. Now further we can see from A and F, there is another resistance 3 ohms is connected. So this part I have already shown. Now I am talking about this point. From A and F, it is connected to a point E. So let's go to the other side of the circuit and draw this 3 ohms and call this point as E. Now let us proceed further. From E to D, you can see 1.5 ohms. So this is E, this is D. So between these two, I shall draw that resistance of 1.5 ohms. That means I have taken care of this also. And further, what else is the remaining thing that I need to take care? This 2.5. See, this is between B and C. We have a 2.5 ohms. So this is B, this is C. So you add your 2.5 ohms. Right. I will draw the remaining circuit later. But if you look at this circuit right now, if you look at this circuit little carefully, it can be noticed that it is in the format of a Wheatstone bridge. You know, in the case of a Wheatstone bridge, if the bridge is balanced, I am not going into that details now. Please refer the current electricity chapter if you don't know how a Wheatstone bridge and what do you mean by bridge is in a balanced state. So if a Wheatstone bridge is in balanced state, but the condition for the bridge to be in the balanced state is P by Q equal to R by S. So you can say this is P and this is Q, this is Q, this is R, anything is fine, S. But look at the condition, then look at the resistances values that is given for you. P by Q is, P is 3, Q is 1.5, that is 2. R is 5, S is 2.5. That is also 2. So P by Q equal to R by S. The bridge is in a balanced state, condition is satisfied. So the rule is, if the bridge is in a balanced state, no current passes. What happens? That implies no current passes between this point A, F and C, D, that is, or else A and D. That means even if there is a physical resistance of 6 ohms between the points, actually no current passes through them. That means that becomes a dead element of the circuit. Even it is physically there, it is not passing any current through it. So it's like a dead element. So once if you eliminate this 6 ohms, this 5 and 3 becomes something like series resistances, 8 ohms. This and this also becomes a series resistances, 4 ohms. So that entire circuit simply comes down to this entire circuit, or else this entire circuit, like what I am talking about, comes down to this circuit. 8 and 4 are in parallel. When two resistors are in parallel, effective resistance R parallel for two resistors is R1 R2 by R1 plus R2. That is 8 into 4 by 8 plus 4. That is 32 by 12. That is, I can say 8 by 3 by cancelling with a 4 on both sides. So this entire part of the circuit is now having an effective resistance of only 8 by 3. This part of the circuit, like what I have circled with a black line. And now I can continue further whatever the remaining circuit that is there. From B, there is a resistance of 1.5 ohms. So from B onwards, that means this onwards, we have a resistance of 1.5 ohms. From that 1.5, we are having another 5.5 in series. So this is 5.5 ohms. From there, there's the battery of 5 volts. From there is another 1 by 3 in series. 1 by 3 ohms. And that 1 by 3 comes back and connects to the circuit. So this is a equivalent circuit of that given problem. So you can see this effective value 8 by 3, this 1.5, this 5.5, this 1 by 3, all of them are in series. So what is the resistance total of the circuit is? Resistance in series means R1 plus R2 plus R3 plus R4. We have to keep on adding, plus 1 by 3. So 1.5 plus 5.5 is something like 7. So 7 plus 8 by 3 and 1 by 3. 3 is the common LCM. 9 by 3, 8 plus 1, that is 7 plus 3. So the value of the entire resistance is 7 plus 3, that is 10 ohms. So the first thing that we have found, which is the most important thing while solving this problem, is finding out the effective resistance of the circuit. Once you have done that, then the problem is over already. You have found the effective resistance. You know the effective voltage that is available in the circuit. Just apply the Ohm's law. V equal to IR. I want to find out the current. Voltage is 5 ohms. I, resistance is 10 ohms. Voltage is 5 volts. So the current is 5 by 10. That's going to be 5 by 10 is half, that is 0.5 amperes. So the answer for the problem is 0.5 amperes. That's how we come to that answer, right? Thank you for watching.